Hi everybody, in today's video we're going to talk about RF frequency coordination to ensure that we don't have any issues with our wireless lavs being interfered by local RF frequencies. So sit down, strap in, and hold on. We're going to do this without an intermodulation in sight. Roll the intro. There are commercially available RF scanning tools on the market, such as the Tiny SA Spectrum Analyzer, which can analyze frequencies from 100 kHz up to 960 MHz, making it a nice match for commonly used UHF frequencies for wireless lav setups and checking for frequencies for use in your area. This is the first half of the battle to ensure good clean airwaves for your wireless gear to use. But that's only half of the battle. When increasing numbers of wireless channels are implemented, the risks of interference between your wireless channels goes up. This is where the benefit of TXAdvance comes in. It will both analyze the current RF spectrum in your area for clean frequencies, but will also calculate the best frequencies to program your specific equipment to take advantage of those clean frequencies without intermodulation between your wireless transmitters. There are two main parts to this setup. The first is an RF scanning USB dongle. These are low cost and readily available on Amazon for less than $60. They come with an SMA connector and a whip antenna, but in my setup I have it patched into a DD SRD Mini RF distribution box, which has a couple Betso bow tie antennas feeding into it. I could plug the dongle directly into a tablet or phone using the whip antenna, but I want to do the RF spectrum analysis using the same antennas that my wireless lavalier kits will be using. The second part of the setup is the software, which only runs on Android devices. When you open TXAdvance on your device, the first thing you'll need to do is create a new list. This is where all the wireless equipment will be documented for your setup. Once the new list is created, we want to go ahead and start adding transmitters. There is a fairly significant list of pre-populated transmitters in the list to choose from. I will select Sennheiser G4 as the brand, and then AW Plus for the model. The Sennheiser AW Plus band runs from 470 MHz to 558 MHz. After adding the first transmitter, I can then keep adding additional transmitters by hitting the Add TX button, and it will automatically add the next transmitter using the same information as previously entered. I also want to set this first transmitter in Group A. Using groups to identify similar equipment allows for easier mods to the entire group at once, rather than making changes to each individual transmitter settings later on. I only have 3 channels of wireless lavs for now, but I also have 2 sets of Deity Hush DIFB kits, so I'll add those next. I hit Add TX and it will bring in another Sennheiser G4 into the list, but then I can click on the entry and then change it. Before changing anything else, I want to change the group for this transmitter to Group B, or at least anything other than Group A, as any changes I make here can get overwritten to its group. If I left this as A, it would ask to modify all the existing Sennheiser lavs that were already entered. The Deity Hush DIFB kits are fairly new, so there isn't an existing entry in the pre-populated list. Instead, I can go to the bottom of the transmitter list and select Custom. The DIFBs have an overall range of 550 MHz to 960 MHz, but it's divided up over 5 different frequency ranges. 550 to 608 UHF band, 614 to 616, which is the guard band, 653 to 663, which is the duplex gap, 902 to 928 ISM band, and 941 to 959.8 STL band. For my use case, I will most of the time run the DFBs in the duplex gap band 653 to 663 MHz to keep the lower UHF frequencies available for talent, and so I'll set my custom frequency range for these transmitters accordingly at 653 MHz to 663 MHz. The transmitters are limited to 20 milliwatt power in this frequency range, so if I ever need more power, I can run them in the lower UHF band 560 to 608 and still keep them out of the AW Plus band and then be able to transmit at 100 milliwatts. But for now, I'll leave it in the duplex gap. The frequency steps for the DIFBs are in 100 kHz increments, and the specifications for these are 300 kHz channel spacings, so that's what I'm going to enter here. Now that's everything entered, and I will update the names for each transmitter so it's clear what each transmitter is for. Next, I will enter a location, assign the SoundCart 2026 list to the location, and set the low and high frequency range for this particular setup, and make sure the exclusion lists are activated. Hit save often, as it does not keep the settings unless the save button is pressed on each screen. Now we're ready to scan. If loop is not selected, it will scan the spectrum one time. Of course, if loop is selected, it will do just that and continuously scan until told to stop. It's probably better to let it scan at least 2 to 3 times just in case a signal is not present at the exact moment it is scanning the frequency at that particular time. Hit scan and watch the results graph out. In my particular location, there is a fair amount of background RF noise in the UHF channel 15 to 19 range and a bump in activity at the channel 33 to 35 range. Now the tool will calculate the best frequencies for each channel of wireless and ensure it will not create any intermodulation between the channels. Each channel can be locked, so the next time a scan is completed and you run the calculation function again, it will leave that channel alone. To save time during the process, you can set specific frequencies that you would like to exclude when doing the scan. There's no sense in doing scans for frequencies that you won't be using. In my case, my transmitters and receivers used for talent are in the 470 to 558 megahertz range, and then my IFBs are working in the 653 to 663 range. So I'll go ahead and make sure that they are not selected in the screen, and I'll go ahead and exclude all other frequencies in order to save time. You can also enter your own frequencies manually, and the tool will still check for intermodulations with other channels. And lastly, you can look at the frequency selected in real time to ensure there are no transient spikes that were not present when the initial scans were done. Okay, so that's it for another video, folks. Thanks for watching if you made it this far into the video. And if you like this type of content, please hit like and subscribe. And in the meantime, when you're out, don't forget, don't make a big noise. Make good sound. See you in the next one.